Welcome back to this YouTube channel. Now we'll be solving examples on integrating factor. Before I continue, do not forget to subscribe to this YouTube channel and click the notification bell to get notified for upcoming videos. The first example here we have is dy over dx plus 2y equals exponential minus x. Just like we did the general method of solving integrating factor, we can also rewrite this to be y prime plus 2y equals exponential minus x. After rewriting this, we introduce an integrating factor. We have to multiply all through with it, so we have our u into y prime plus 2y equals, remember what I said earlier, we don't actually make use of the right hand side for the main time, so we'll just use what we use in the general method, all prime. Okay, so expanding the brackets, we have our y prime plus 2uy equals uy prime plus yu prime. Now we have uy prime at the left hand side and uy prime at the left hand side. These two can cancel, like I explained earlier from the previous video, because they are both same thing, you can collect like terms. And when they cancel out, we will be left with 2uy equals yu prime. Y also can cancel out y, and we'll be left with 2u equals u prime, which is the same thing as 2u equals du dx. Also, by cross multiplying, we'll be left with du equals 2u dx. Now we want like terms to be together, we have to divide both sides by u, and when we do so, we'll have du over u equals 2 dx. Okay, now it's time to take integral of both sides. We take the integral of both sides, we have 1 over u du equals integral of 2 dx. Integral of 1 over u is ln u from our knowledge of integration, while integral of 2, we have it to be 2x. Okay, so to eliminate the ln, we have to take exponents of both sides. When we do so, we have our u to be exponential 2x. Now this is not just our answer, we have to go back to the integrating factor. Here we have to go back to this place and substitute our value of u, and that is when we will now use what we have at our right hand side. Now, substituting the value of our integrating factor into the equation I mentioned earlier, we will have it to be exponential 2x into our y prime plus 2y equals exponential 2x. Now we are going to multiply with what we were given at the right hand side from the question, so we have it to be exponential minus x. Okay, this expansion we have here is the same thing as you saying exponential 2xy all prime. Yes, when you take the differential of the product of the two, we have that expansion there, and this is equal to exponential 2x multiplying exponential minus x, which equals exponential 2x minus x, which is equal to exponential x. So this is equal to exponential 2xy prime equals exponential x. Now to eliminate this prime, don't forget this prime is representing differentiation. We have to take the integral of both sides. Taking the integral of both sides, we'll be left with 2xy equals integral of exponential x dx. Okay, now from here we have it to be exponential 2xy equals, when we integrate exponential x, we'll be left is the same thing as exponential x, since the coefficient of x here is 1 plus our constant a. Okay, so we divide both sides by exponential 2x since we are looking for y. Our y will be equal to exponential x plus a all over exponential 2x. So this can also be written as y equals exponential minus 2x into exponential x plus a. This is our final answer. If you like, you open the bracket, but it's still the same thing. So let's solve it further. We had our y giving us exponential minus 2x into exponential x plus a. Okay, when we open our brackets, it will be exponential minus 2x dot exponential x plus a exponential minus 2x, and this will be giving us exponential minus x plus a exponential minus 2x.